Hey everyone, welcome back to the Generative AI Learning Series by StarAgile. In this series, we'll continue to explore generative AI and how it's changing the way we work and create. If you're curious about AI or eager to learn more, you are in the right place. I'm Josefa, and I'll be your guide throughout this journey. In this fourth chapter, we are going to be discussing RAG with FAISS. If you have missed out on any of our previous videos, don't worry, here is the link for you to check them out. So let's get started. Hi everyone, in this session we are going to discuss the concept of RAG, which is retrieval augmented generation, and how you can use RAG to develop document aware chatbots using Langchain and FAISS vector stores. So let's get started. So we'll first discuss the concept of RAG itself. RAG stands for retrieval augmented generation. With the help of RAG, we are able to first retrieve all the relevant documents from a particular database like FAISS. Based on the user query, the vector store will retrieve all the important documents matching the user query, and then will take all those relevant documents, create a context and put it inside a prompt. And finally, the prompt will be fed to the large language models to generate a more grounded and accurate answer for the corresponding user query. So eventually, RAG allows us to combine the capabilities of a search engine with a large language model. Why do we need RAG in the first place for this? The reason being, LLMs on itself do not have access to your company's documents or any official documents that are not available in the open source development. Say for example, you are working for an e-commerce company, and an e-commerce company like Amazon can sell hundreds of different products. And each product can have different return or refund policies. If a customer has purchased a certain item and they wish to return it, they might have an interaction with a chatbot wherein they ask, what's the refund policy for my given item? Now, a chatbot might not have access to a company's refund because at the back end, it will call a large language model and feed the query that the user has given to generate a response. Now, if this LLM has been trained on any open source data, then eventually it will know only the facts about whatever is present in this open source data. It will not know any information about that specific company's policies. So there is no information available with the model to understand what the policy of that company are, and hence it will not give an accurate response for the query that we have provided it. So how do we overcome this problem? Here RAG will help you. Here RAG comes to our rescue. So RAG will let AI get all the facts from the relevant documents, and then it will look at those documents before generating the answer that we want to get. So without RAG, AI will make generic guesses, right? Its response will not be accurate, which can lead to bad customer experience as well. With the help of RAG, AI will use the real information which is pertained inside our data set and then use that information to generate the accurate answers. Right? So for example, if the customer is asking us what's the refund policy for the item, then the RAG will look at the refund policy for that specific item and then generate the response by looking at that policy only. That's basically the benefit of using RAG with large language models. Now talking about the vector store that is recommended, it is FAISS. FAISS is developed by Facebook, which stands for Facebook AI Similarity Search. Right? So that's the full form for FAISS. This tool has been developed by Facebook, and the reason for using this tool is, first of all, it has excellent capabilities of retrieving answers at a very small period of time. It searches across documents extremely fast. There is no dedicated server required to set up FAISS. You can install it and run it as you run any other software application in Python. Right? Just install the package, set up the document store like we did in the previous session, and you are good to go. Right? And it's fairly easy to demo and test and practice as well. So that's the major reasons why we are using FAISS for this particular demonstration as well. Talking about the end-to-end workflow of how this application would look like. So as a user or as a developer, you would first take all the company relevant documents and load and split them inside a vector database. Right? So we'll take the documents that are relevant to that particular company's policies, take those documents, load them, split them, and finally embed them inside a vector DB. For embedding, we can use different embedding models. You can either use OpenAI models or you can also use Hugging Face models as well. It's any of the two models can be used. For our demonstration, we'll be using Hugging Face for embedding these different documents. Finally, once these models or once these documents have been embedded, we are going to store them inside our vector store, which is going to be created using FAISS. And finally, once the document stores is ready, we can use that to retrieve the relevant information or relevant documents based upon an input query and create a context and send it to our large language model for further processing. Let's implement this using Python really quickly. So here we are inside our Jupyter notebooks, and as always, we'll begin by importing the dependencies first. We'll use load.env function to load the environment variables. This includes our OpenAI API key. Chat OpenAI will allow us to instantiate our large language models. So this will allow us to interact with OpenAI and get the responses from the LLMs created by that company. Hugging Face embeddings is the model that is the class that we will use to use Hugging Face models for generating the embeddings for our documents. FAISS is our vector store inside which we will embed our documents. Chat prompt template and the messages placeholder will allow us to create a prompt template such that the large language model will know the context as well as the previous message history that has happened between the model and the end user. And finally, we'll use the text loader to load our document text and recursive character text splitter to split those into small chunks. We'll first start by loading our environment variables. Once our environment variables are loaded, we'll begin by importing our document. So first, let's take a look at what data we are going to ingest in our vector store. So here we have created a simple document that contains a refund policy for a company. It says that customers in this company can request a refund within 30 days of purchase, item must be unused, and finally they can even send an email to this particular email ID if they wish to have any additional support for their particular refunds. So here we are going to load this particular document using our text loader function. So here let's create a loader first. Right, so here inside this loader we are going to feed the file text data.txt, and then let's load the documents by calling the load function here. Let's print it and verify whether the document has been loaded correctly. So as you can see, the source is data.txt and the content of this page is what I have shown you on this particular on this screen over here. So once our document is ready, we can then split it into smaller chunks. So for splitting it, we can create a splitter. Right, so here we'll create a recursive character text splitter. We'll reduce the chunk size to, let's say, 50 characters and an overlap of, let's say, 30 characters. So this splitter that we have created will allow us to split our documents into smaller chunks. Remember, it's not mandatory to create a splitter. Use this only when your document is too big to be ingested in one single shot. Okay, so right now for demonstration, we are using the splitter, but it is not mandatory that you need to split every single time you need to ingest. Right? So once our splitter has been created, we'll then create our chunks. So here we'll be able to create our chunks, and these chunks will be passed individually to our embedding model, and the embeddings for each chunk will be stored in our vector store. So next is to create a vector store itself. So here we are defining a vector store using FAISS, and here we'll use the from documents function to embed the documents, right? And at first we haven't created our embedding model yet, so first let's define our embedding model itself. So let's create an embeddings model, right? And the embeddings which we will create will be created using Hugging Face embeddings. And the model is basically the sentence transformer model that contains all mini large language model, right? So this is basically the model name that we'll use for embedding each document text. We'll create our vector store. It's going to take a couple of seconds for running. Right. So now our documents have been embedded inside our vector store. Next up, let's also create a retriever that will allow me to retrieve the documents based upon a user query. After this, what we need to do is we need to define a function that can take an input text and that can take the embeddings that we have created and then retrieve the documents based upon which is the most matching one. So here what we will do is we'll define a function. Let's call this function as getResponse. This function will take two things as an input. The first one is the input text, and the second parameter is, let's say, a chat history. So this input text is going to be the input given by the user, and chat history is going to be the history of the previous conversations that we have had with the language model. First thing that we are going to do is first we'll retrieve all the matching documents from our vector store corresponding to our input text that has been generated. So here let's first retrieve the matching documents. And here we'll use the retriever object that we have created above, and we'll get all the relevant documents corresponding to the input text that we have provided. Once we have these relevant documents, then we are ready to define our context. And context is nothing but a line by line, it's basically a string that contains all the relevant documents in each line, right? So imagine that we get 3 documents back. So what our context will contain? So this context is basically going to be, in line 1, we'll have the text from the first document. In line 2, we'll have the text from the second, and line 3 will have the text from the third. So like this, we'll basically create a string that contains the text relevant from the retrieved documents. Okay, that is what our objective here is. So over here, we are going to create, or we are going to basically define this, and we'll use the join function to join a list of text that we are going to retrieve. So here we'll use the page content. So this will return me the content for that document, and we'll iterate through each of these documents inside our matching documents class that we have created above. So this matching documents will retrieve all the matching relevant documents, and we'll iterate through each one of them, and we'll append that respective page's content in a new line. So once our context is ready, then we are ready to define our prompt template. Or first let's define the prompt template outside. Let's create a chat prompt template here itself. So here we'll define a chat prompt template, and this template will be defined using the functionality for messages. And here the messages that we will append, the first message that we will create, let's create a system level message first. The system level message will basically contain the instruction that the large language model needs to follow. So here we'll say you are a helpful assistant. That can answer the user questions based on the context given, right? And we'll also say if you do not know the answer, just say I don't know. Right? So basically we are mentioning this particular template that first of all what you need to do is you need to look at the context below, and also we'll create a placeholder for providing our context as well. So here we'll mention the context here. Let's write it within the text bracket only. Okay. So in this particular case, the first thing that we have done is initiated a system prompt. This system will basically say that the assistant is going to answer the user's question by only looking at the context provided. Right? And if the model does not know the answer, then they will just reply saying that I do not know. All right, and let's also define the context in another line. Let's put the context here. Okay. So here we have provided our context, and after the context we have mentioned the model that you do not know the answer, just reply that you do not know the answer, followed by a placeholder for messages history as well. So next up what we are going to do is we are basically going to devise a messages placeholder, and this messages placeholder is going to contain all of our previous chat history, right? So I think I have imported it above, so let's define an object of the class messages placeholder itself. Okay, so here we are going to define the object of the class messages placeholder, and here the variable that it will be storing is known as chat history. So we'll pass the chat history that we will retrieve in this step as an input to the messages placeholder, and lastly we'll also give the user's input. right? So this is basically the question that the user has requested us for answer. And this is basically a prompt template that we will feed to our large language model as well. Okay, so this is basically the template that we are going to follow going forwards. And in order to make it a little bit more explicit, let's add a couple of lines here and we'll mention the keyword context followed by the context that the model needs to look at, right? So I'm just making it a little bit more structured here, saying that the first line will contain the instructions followed by a couple of additional lines, and then we'll write the context followed by that, and finally a last instruction that will tell the model to reply saying it doesn't know anything if the context is not enough. All right, that is what the template will look like. So now our prompt is ready, and the second thing that we have to do is basically define our chain. So in this particular case, the first part will be to use the prompt template followed by the input to our large language model. So in this particular case, we need to use a large language model. So let's define this large language model just above. So for the large language model, we are going to use the chat OpenAI, and here we are going to use the model GPT-4o mini. Right, temperature is not required here. Let's remove temperature and we'll set the API key here as the OpenAI API key that we have loaded already using our environment variables. So likewise, what we will do now is we have defined a chain that will take first the prompt template. We'll replace the prompt template with the respective keywords here. So context will be replaced by the context. We'll give the chat history, and finally we'll also provide the input that the user has given. Now let's go back to our get response function and complete this out. So as you can see, we have first retrieved the context. Now all we need to do is basically we need to get the response back from the model by saying chain.invoke. And in this particular case, what we are going to do, we are going to replace each placeholder with the correct value. So input will come from the input text, context has already been created above, and chat history is also an input to this function. And what this function is going to return, this function is going to return the response that is generated from the large language model. So now let's test it out by using a simple prompt. So let's basically call this function once and let's ask it a simple question. So what is the refund policy for your company? So right now the chat history is empty because we haven't had any conversations yet. So we'll basically give a blank chat history for now. And let's see what the response is generated by our model. Right, so as you can see, the message that we have received is an AI message, and it clearly says that the customers here can request a refund within 30 days of purchase. Right, so this particular query is giving us the right answer because looking at our policy as well, you can see clearly that it is written that customers can request a refund within 30 days of purchase. But that's not it. We can even take it one step forward and create a chatbot kind of an interface. So in order to do that, let's first create a chat history which is currently blank. And then we are going to iterate, right? So while the loop hasn't ended, so first thing that we will do is we'll ask the user for their inputs. Right? So here we'll ask the user what your input is, and we'll first check if the user input is basically exit. If the user wants to exit, that is the user wants to exit the chat, we'll just print exiting the chat and we'll break out of our loop. If not, we are going to generate the response from the large language model by using the function that we have defined previously. The inputs will be the user input that we have currently received and the current chat history that has been generated. And then let's also print the user input as well. Right, here we'll print the user input and the corresponding AI input as well. And for the AI response, we'll use response.content. Remember, this is basically an AI message object that we will get. In order to get the text response, we'll need to use the content attribute within it. So I'm going to use response.content to print the content received back from the AI model. And finally, I'm going to append within the chat history, firstly my human message, which is basically generated from here. And finally, we'll also append our content which we are getting back from the model. So here we'll just respond with the response here because response already is an object of class AI message, so I do not need to wrap it again. So here what we have done, we have successfully created a loop that's going to wait for a user's input, verify if the users want to exit the chat, print if it's exiting, otherwise get the response back from the large language model, print what the current user inputted, print what the AI response is, and finally append it within our chat history in order to continue the loop. Let's see this in action as well. So here, as you can see, it's waiting for my input. Let's say I want to know the refund window. So here, as you can see, I gave a response which is basically I want to know the refund window, and the AI has responded back saying customers may request a refund within just 30 days of purchase. Let's continue and let's also ask what's the customer care email address. So let's type it again. What's the customer service email address? And you can see here, after writing it out, it is basically saying that the customer care email address is basically support@example.com. And you can go back and verify whether this is right or wrong. It's actually the same email address that we have provided within our prompt template as well. So now if we are done, we can simply type out exit, and that will essentially exit the chat, saying that we are done with our chat conversation. So as you can see how easy it is to use Langchain to develop a RAG based chatbot agent. That's all for this session. In the next session, we will start with the agentic framework using Langchain. So I'll see you in the next class. Thank you very much. If you found this video helpful, don't forget to hit the subscribe button and give it a thumbs up. We've got more exciting Gen AI episodes coming your way very soon. Also, if you are looking to earn a globally recognized certification in automation testing and Gen AI, be sure to check out the StarAgile certification courses. Thanks for watching and keep learning. I'll see you in the next video.